Safe to say COVID's got everything a little bit crazy at the moment. So on that point, I figured it'd be time to build our very own face mask detector. Let's take a look at what we're going to be going through. So we're going to be going through three key things today. Specifically, we're going to take a look at how we can capture images with OpenCV. We're then going to take a look at how we can train a custom object detection model using Watson visual recognition. So this will allow us to detect different masks. So in this case, we've got a white mask and we've also got a black mask using machine learning. And last but not least, we're going to take a look at how we can visualize these detections using Python and OpenCV. So we'll be able to take the result of our scoring request and visualize that on an image that we've got captured. Now, in terms of how we're going to be doing this, we're going to capture our images initially using OpenCV and Python. So for that, we'll be using a video capture device. We'll then take those images and upload them into Watson Studio. This is going to allow us to train and label our different images so that we can detect masks versus not having a mask. And then last but not least, we're going to take an existing image on our local machine and we'll send a scoring request to our Watson visual recognition service to be able to detect masks inside of different images. So you can then take this code and deploy it wherever you need to so that you can have it live and in production. Ready to get to it? Let's do it. So the first thing that we need to do in order to build our face mask detector is get some images of face masks. Now what we're able to do is use OpenCV to collect those images. So let's lay out our Jupyter notebook and start collecting our data. So in order to build our face mask detector, there's three key things that we need to do. We need to collect some images, train on Watson Discovery, and once we've built our model, we can then use our Python SDK to actually make scoring requests and visualize that data. So the first thing that we're going to do is make sure we lay out our Jupyter notebook so that we've got a nice flow to work with. So let's go on ahead and do that first. So there's three key sections. So the first one is getting images, then scoring within our Jupyter notebook, and then visualizing. Perfect, so that's our layout done. So now what we can actually do is use OpenCV to grab images of us in a mask and without a mask. So in order to do that, we first need to import some dependencies. So let's go on ahead and do that. Perfect, so those are our dependencies imported. So we've imported OpenCV, so this helps us work with image data, and we've also imported UUID. So this is going to allow us to create a unique identifier for each image that we create. Next, what we need to do is create a video capture device. So this is going to allow us to capture images using our webcam. Perfect, so that's our video capture setup. So what we've basically done is we've used the video capture class from CV2 and we've passed the number 2. So you might need to play around with this and basically find the video capture device that is your webcam. So for my Mac, it's going to be video capture device 2. And then what we've also done is we've extracted the frame width and the frame height. So that's going to allow us to capture the dimensions of our specific webcam. So now what we can actually do is go on ahead and capture our images. So in order to do that, we're going to be using the cv2.imWrite method and cv2.imRead to show the values to the screen. So let's go on ahead and get that started. Okay, so we've written quite a fair bit of code there. Now let's quickly walk through what we've actually got. So the first line of code is going to allow us to capture our image from our video capture device. So this is going to allow us to grab our current frame. Then what we're going to do is store our image or define our image path and then write it out to a file. Then what we're able to do is show that particular frame. And if we want, what we can do is use the wait key to quit out of our CV2 capture device. So sometimes when you're working with this inside of a Jupyter notebook, it might get a little bit buggy. So having that wait key is going to allow us to escape out of that and stop our video capture. Now, the last thing that we need to do is make sure that we release our video capture device. So let's go on ahead and do that. Okay, so now that we've got our code, what we want to do is actually capture some images. So first up, we're going to capture some images of some masks. So I'm going to bring down the green screen and let's capture some images with me with a mask. If you're doing this yourself, so capture some images of yourself with a mask. Perfect, so that's our first set of mask images. So now if we go into the folder, which is images/mask, we should have some mask images. So I'll just open that up, images, mask, and you can see we've got a whole bunch there. Now, what we should do whenever we're training these models is try to get a variety of data. So in this case, I've got a white mask, but what we might also do is try it out with a black mask. So let's go on ahead and do that. Alrighty, so now we've got our black mask images. Now the last thing that we're going to do is capture some images of me without a mask. So in this case, we're going to put those images inside of the no mask folder. Perfect, so those are all of our images captured. So if we take a look, we've got some images of a white mask. We've also got some images with a black mask. And then let's just make sure we've got some images with no mask. Doesn't look like that's work. And because we haven't defined our file path right. So if we put in a space there, that should work. So let's go on ahead and do that again. So let's take a look in that folder and you can see we've now got a whole bunch of images without a mask. Perfect, so that's the large majority of our image capture done. Now let's go on ahead and train our machine learning models. So in this case, what we're going to be doing is training our visual recognition model using Watson Studio and specifically using Watson Visual Recognition. So in order to do that, all we need to do is go into IBM Watson Studio, hit Add to Project, and hit visual recognition. Now, in this case, we don't have a visual recognition service already associated to our project. So all we need to do is hit create a new one. And from here, what we can do is create a new instance of our visual recognition service. So all we need to do is hit new, hit light, and then hit create. So light is going to allow you to perform up to 1,000 visual recognition events per month. So that's more than enough if you're just getting started. So go on ahead and hit light and hit create. Then hit confirm. And once that's done, we'll be able to start uploading our images and start training them to detect masks and no masks. So now that our visual recognition service has been spun up, all we need to do is select detect objects and hit create model. So if you wanted to build an image classifier rather than an image object detector, then you'd select classify images. In this case, we're going to be using the object detector. So just hit create model. So then from here, what we can do is start uploading our images. Now in this case, we're going to upload some images where we have a mask on and some images where we don't have a mask on, and then we're going to label. So in order to upload our images, all we need to do is hit browse and then navigate to where our images are. So in this case, we're going to grab some no mask images and hit open. These are then going to upload into our project. While we're at it, we'll also upload some mask images. And hit open as well. Perfect. So now we've got a whole bunch of images within our visual recognition project. Now what we need to do is label these images. So identify images where we have a mask versus those where we don't have a mask. So in this case, we've got a variety of images at different angles. So this is going to help our machine learning model perform a whole lot better. So now what we can do is start labeling. So in order to label, all we need to do is select an image, hit add object, and then trace where that particular object is. So in this case, I'm going to trace around my mask and then type in mask and hit add. Okay, so now we've labeled our mask. Likewise, we can keep going through and adding labels for our mask. And we can also step back out and do some where we don't have a mask. So in this case, I'm going to label that I don't have a mask here. And we're just going to call that label no mask and hit add. So we're going to speed through this and label all the images, but basically what we're going to do is just do the exact same. So we're going to label some images with no mask and those with a mask. So let's fast forward and smash through that.
5 minutes later.
So that's all of our images labeled. So you can see if we flick through all of them, we've got labels with masks. And if we step out, you can see we've got a whole bunch with no masks. Now, once we've labeled all of our images, all we need to do is hit train model, and this is going to go off and train our machine learning model. Now, this might take a couple of minutes, so I'll see you again once it's done.
A little longer than a few minutes later.
So now that our model's finished training, what we can actually do is step out of it and test it out. So from this screen, we can see that our model is ready for use. We can see that we've also got 34 images and we've got our different classes down the bottom here. Now what we can do is we can actually test this without even using OpenCV. So if we wanted to, we can hit test, hit browse, and then choose the images that we want to test out. So in this case, we can open up some of our images where we don't have a mask and hit open. And what you'll see are the results of the object detection model. So you can see here that it's actually picking up that we don't have a mask and it's got a reasonable level of confidence. So in this case, we've got 94%, 94%, 93, 93, and it's actually gone and picked up that we don't have a mask. Likewise, we can also clear these results and upload images where we do have a mask to see if it picks that up. So if we, again, go into our images, select mask, and then select a number of images where we do have a mask, and hit open, you can see that our model is now picking up that we do have a mask with a reasonable confidence interval. So again, we can change our thresholds and you can see that it's actually picking up that we've got a mask. So this allows us to work with it using our IBM Cloud Pak for Data and Watson Studio, but if we wanted to, we can also work with this using Python or OpenCV as well. So in order to do that, we're going to jump back into Jupyter Notebook and start writing our code that we need. So in this case, we've gone and trained our model inside of Watson Studio, so we can say that that's done. Now what we're going to do is start to build our scoring components. So in order to do that, what we need to do is first import our dependency. So let's go on ahead and do that. Perfect, so those are our dependencies imported. So what we've done is we've imported JSON, we've also imported the visual recognition class from IBM Watson, and we've also imported some helper classes. So in this case, file with metadata and analyze enums. So file with metadata is basically going to structure our images as a file that's easily used with the visual recognition service. Analyze enums is basically going to allow us to extract our results. And last but not least, we're also importing the IAM Authenticator class to allow us to authenticate against visual recognition. So the next thing that we need to do is grab our API key, our service URL, and our collection ID. So we can grab all of these from Watson. So let's go on ahead and create variables, and then I'll show you where to grab them. So in order to get our API key, all we need to do is go to cloud.ibm.com, and from there we can hit our resource list and then bring up our recognition service. So in this case, when we created our visual recognition service, we were able to generate service credentials. So all we need to do is step into that service, and then we can copy our credentials simply by grabbing our API key there. So we're going to grab that and paste it into our Jupyter Notebook. We're also going to grab our URL, and again, paste that in. And our collection ID is actually going to come from our trained model. And all we need to do to grab that is copy this collection ID here. Perfect, so those are all the variables that we're going to need to test out our model. Now what we can do is authenticate against our service and then score. So let's first up authenticate. Perfect, so that's us authenticated. So basically what we've done there is created an instance of our IAM Authenticator and passed through our API key. We've then created a new visual recognition service and passed through the version of the service that we want to use, as well as our Authenticator object. And last but not least, we've specified our service URL. So this is basically where our visual recognition sits in the World Wide Web. So all we've done is pass through this URL here. Now what we can do is actually go and score against our image. So in this case, we're going to grab an image. So we'll grab one from our mask files. So we'll just copy that file name, and then we'll just create a variable for that. So remember, our images are inside the images file and inside the mask file. directory, sorry. Now we can go ahead and use our visual recognition service to actually go and analyze our image. So let's go ahead and do that now. Perfect, so we've now just gone and scored and analyzed our image. Now what we can do is grab the Analyze Images object. And you can see we've actually gone and extracted all the categories or the objects detected within that image. So right down here, you can see that it's detected a mask and it's also given us the location of where that mask is. We've also got the score or the confidence interval to tell us how well it's actually gone and predicted. Now, the last thing that we can actually do is use OpenCV to actually go and visualize that on our specific image. So in order to do that, we just want to extract two key things out of our Analyze Images component here. That is the object that's been detected as well as the coordinates. So let's go on ahead and do that. So what we've basically done here is we've just grabbed the Analyze Images object and we've just traversed all the way down through to grab one, our object, and then second, our location. So this basically allows us to grab our object. So if we print that out, which is a mask, as well as our coordinates, which we have there. Now all that's left to do is actually go and visualize this on our image. Now in order to do that, we're going to be using CV2 or OpenCV, just like we did before. So let's go on ahead and do that. The first thing that we want to do is import Matplotlib. So this is going to help us with visualizing our image. Then what we can do is read in our image. So in order to do that, we're going to use the cv2.imread function. Perfect, so that's our image. Now, when we look at our image, it's just a number of different arrays, and this is because when we read it in, it's going to read it through as an array, because an image is really just three different sets of an array, one for each channel, so R, G, and B, and it's represented as a number between 0 and 255. Now what we can do is recolor our image, so CV2 reads it in as BGR, we want it as RGB, so let's go on and do that. Perfect, so we've now recolored our image. Now what we can do is take a look at our image and you can see that we've got our image of our mask, but right now we don't actually have our square displayed yet. So let's go on ahead and place our square or our rectangle to represent our detected object. Now we can do that using the cv2.rectangle function. So let's go on ahead and write that code. And you can see we've now included our rectangle or our detected object inside of our image. Now what we've actually done using the cv2.rectangle method is we've passed through our image as well as the top left corner. So in this case, it's our left coordinate as well as our top coordinate. And then what we've done is we've passed through our bottom right-hand corner. So in order to calculate that, we've taken our leftmost coordinate and added our width to get to here. And then we've taken our top coordinate plus our height to get down to here. And that has given us our square. The last two parameters are the color. So in this case, we've passed through a bright green and the width of the line. Now, the last thing that we can do is add in some text so to read out that we've actually detected a mask. So let's go on ahead and quickly do that. And there you go, we've now gone and added our text. So what we've basically done is we've used the cv2.putText method, we've passed through our image, we've also passed through the text component. So in this case, we passed through our object, which is obj, which reads mask, and we've also included our coordinates. So for our particular coordinate, we wanted it to be in the bottom right-hand corner, which was the same coordinate that we had for our rectangle up here. We've also specified our font face, our font scale, as well as the color, thickness, and line type. And that about wraps up how to build a face mask detector using Python and Watson. So just to recap, so we captured our images using CV2, we then built a detector using Watson visual recognition. We then deployed our model and then went and scored it and visualized it again with CV2 and Python. Thanks so much for tuning in, guys. Hopefully you found this video useful. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of any future videos. If you've got any questions at all or need any help, be sure to drop a mention in the comments below and let me know what kind of face detector you ended up building. Peace.